So this is an example of picking up. We actually managed to pick up outliers. This was a bad sensor. What we do is during a chunk of time, because we can't do across a whole bunch of time, we actually run this K-means algorithm, and we can, in this case, all these blue dots belong to one sensor. So we can very quickly assume that here we have 4 temperature probes, all actually giving you a value that's completely different than the rest of the community. So we can begin to assume there's some problems here. Okay, so the other thing we also did was look at network problems. So that's another issue that is important. So we looked at the temperature values and said, okay, how good is our sensor data? And then we said, well, how good is our network performing? And the whole idea behind this is to see if we had packet loss, delays, or actually delays not an issue as much, but mostly packet loss, duplicate, and topology changes and reliability. Actually, we had really 0 packet loss. The system basically was quite reliable in transmitting the data. But interesting enough, we do have duplicate packets. That means the packet ends up going through 2 different routes, and it gets duplicated, or for some reason it gets retransmitted. We don't know why, but it'll get retransmitted. And therefore, it's part of the routing algorithm. The reliability, though, is a main concern. It wanted to, for example, get these working up here in college, because they have a vineyard here. I don't have a vineyard. But I couldn't really get them out of my site, because we could only operate at times several days, 14, right now I think we're up to 14 days, before something occurs to one of the nodes. And so it's very challenging. In the fall 2009, we had a major problem with the gateway. And what's really kind of annoying is that we use, for example, operating system to help us. And then when the problem occurs, we then have to dig into the operating system, right? We have to actually dig into someone else's code and dig into the operating system. And that's really quite difficult. You really have to understand what's going on at that point. So we recovered from one, and now we have another one, but it's a lot more stable than it used to be. That's actually promising. So now this is the topology that we get, roughly. I don't see it yet. Here's 0. So 0, I told you, was in my office. It's a collector. And interesting enough, this particular topology is formed, and this nodes 7 and 3, they periodically switch, and they become kind of relays. Don't forget, these are not design relays. They also have sensors on them. So these things behave as relays and sensors themselves. So it's not like we have an actual dedicated relay. So they flip back and forth off and on, and around 9% of the time, I forget which one it is, 9% of the time I believe it stays on 3, on 7, and then the rest of the time it's on 3. Yes, 5 minutes. Okay, so like I mentioned before, we have some current reliability concerns occurring in the system. Sometimes the system, when node 3 stops working, that means it stops transmitting data, actually it doesn't reconfigure itself. So that's a problem in the routing algorithm. And it's quite possible that no alternatives exist, but we've seen that 7 is an alternative. But maybe 7 doesn't truly connect properly to another node, but that requires some investigation. All right, so we capture data, we put it in a database. It's relatively simple. We capture data, normal load means this is all data. So this is actually just captured this morning, I think it was. Yeah, 7:30 in the morning, look that up. And this lets us simply quickly see through a web page what, if the system is operating, what the temperatures are. You see the weird things, sometimes a bit. 220, it's not a good temperature value. What happens is, again, the sensor has places at which we know when you start getting low voltages, you start getting these really bad sensor readings. That's what happens. So then we do have thresholds to deal with that. And this is actually discovery message information. This is, in fact, again, a Google Earth view of the sensors. You know, we had the same situation as York City, where you see there's no building here. I actually have an office right here someplace that doesn't exist. And we have found that it's all flat. It's not flat. So Google Earth has its problems. It's actually, there's a valley there, so it's not well done. This is actually another type of image from a vineyard, but with fake data. Let me just get into geo positioning quickly. We did some work on using RF signaling for positioning of sensors. The problem is that you don't get nice data. This is in fact a typical RF signal given distance and power, and you see that it fluctuates like crazy. So it's quite challenging to use RF signaling, but we still managed to use an optimization algorithm, which is an ordered algorithm. We actually didn't use, we just ordered all the distances and managed to get, for example, some values. Here's an example of the values of our positioning. This is where it believes, the tips of these arrows is where it believes a node to be. This is a 16 by 16 set of nodes put out in the field, and it actually believes that the node is here based on this localization algorithm that we developed. So this is the error. This is basically the error that we see in here. So the error is about 0.11062, and this is actually without the algorithm. Okay. Some comments about it. We underestimated the time significantly. It's a 2-year project. We were hoping to get out in the field twice. Actually, we did get out in our field, but not in the vineyard. We did get out actually twice. So, but we really thought that we could take all these components, put them together in much faster, and get it running much quicker. But in reality, we have found problems that arose from this. The software development in SC and TinyMS is rather unique, and it's rather complex. It takes time to learn it. In fact, I'm teaching a course on that this summer. And embedded programming is really hard to debug because the problem is that you can't connect to the sensor. The sensor fails, stops communicating, well, you can't connect to it. So you can't actually get to it and say, send me some of your recent results because the communication is down. So you actually have a really challenging issue. Okay. I'd like to just make this point. There are certain types of problems with sensing networks. I spend quite a bit of time talking to vineyards, talking to greenhouses, because I'm interested in greenhouses. First of all, the area cannot be easily wired. That seems to be obvious, but that's not the main problem. I'd like to explain why that is. We went to a greenhouse, and the greenhouse is all wired. And those greenhouse people, they don't care if it's wireless, because they don't have very much reconfiguration. So once the greenhouse is wired, then why would they go to wireless? So in fact, they won't jump up and down and say, yeah, this is really fantastic. Because they don't reconfigure very often. They regrow the same thing over and over again. They do it often enough. And also, you need a high local spatial resolution. Why am I saying that? Well, because if you only need one sensor, and you can measure one sensor for, say, 1 acre or 5 acres or whatever, maybe 1 acre, then don't put a sensor network in. Okay, this is my last slide. My research area is in software development and distributed systems, like I said. I'm quite interested in looking at integrating the sensor network to actuators. The sensor network by itself may tell you something, but in reality, make it do something. Turn on some valves, optimize the system. That's why the greenhouse I was interested in, and still I'm pursuing that, because you can optimize the operation of a greenhouse with sensing equipment. And in fact, it is. If you've ever seen one, it's quite impressive. In fact, there's one out here, I guess. You should see that one. I use sensor modeling languages to generate code. I'm looking at that. This means automatic generation of code based on components and process-based modeling. So I'm very interested in improving the code process of sensor networks. The problem is we have great, wonderful things for service-oriented architectures, but you can't run any of them in the sensor network. You cannot run those protocols. You cannot run those types of specifications. Okay, so I'll stop with this one. This is just the partners that we had in our project.